Well, welcome everybody. Thanks for taking time out of your busy schedule. I know we have a full house here, so that's awesome. My name is Dave McPhail. I'm the President and CEO of MEMEX. MEMEX's tagline is Measuring Manufacturing Excellence. It's exactly what we do. We're a hardware and software company that brings the industrial Internet of Things to life in pretty much every genre of manufacturing, and I hope to take you on a bit of a journey here for the next 30 or 40 minutes. I'll leave some time for a Q&A at the end. Okay, so with that, let's go. This is what we're going to cover today. We're going to cover data streams required to fuel an IIoT implementation. We're going to cover impactful continuous improvement. We're going to talk about the factory of the future, IoT, what's all the fuss about, some convergence between IT and OT that has to happen. We're going to talk about some pragmatic use cases, automated OE tracking, roadblocks to adoption, some examples of benefits, a summary, and then the Q&A at the end. So with that, let's get started. So data streams required to fuel an IoT implementation. So the drive towards connectivity. None of this happens without having our assets on our factory floor connected. Okay, we need to pull the data out. We're big proponents of MT Connect. For those of you that saw Neil's presentation, he went into a great amount of detail. I'm not going to do that. Just suffice to say that we're huge supporters of MT Connect and have been since 2010. Some of the drivers include higher customer satisfaction, competitive agility, lowering production costs, and obviously greater productivity. And when we do this right, we have essentially a circle here of customers, suppliers, the shop floor, and management, all using one version of the truth to affect change on the floor and increase our productivity. So this is an example. I get asked this question a lot about, well, how do we connect? I understand if we buy a brand new piece of equipment, as an example, a Mazak machine, and it's MT Connect compliant, but what about all of the rest of the assets on the factory floor? How do I connect those? So we have a product called the AX760, and it essentially turns that machine into a web server and speaks MT Connect. So it's essentially an Ethernet connectivity device, and it will go into machines that presently, in most cases, don't have an Ethernet connection, or if they do, they speak some proprietary protocol. So it saves us a lot of time and effort, and it actually lowers the barrier to entry for our customers. If you want to, the show's going to be over when this is done, but we did have a booth at 2617 down the road here, and we did have a sample of that there. This is an example, three pictures of three older controls. Some of these controls are 20, 25 years old. We're able to actually pull some data out and actually create a very compelling business outcome, which I hope to share with you in a few slides. So when we look at the data required to fuel an IoT implementation, there's really the confluence of three data streams. So we have data from the operator. This is an often overlooked but very important data stream, because the operator is essentially an important piece of the puzzle with respect to the productivity of the factory. The operator can influence the productivity of the factory. It also can improve the productivity of the factory by giving us information that we currently don't have, like the machine's not running, and it's not running because the operator doesn't have the tooling to run it, or doesn't have the dunnage to put the finished parts in, or things of that nature. We can take that data back. We can actually fuel our continuous improvement initiatives with real-time data. The second piece of data that's important is our business system data integration. So we want to be able to take the production schedule to and from ERP, take the production schedule from ERP, drive it down on the factory floor, have the operational management team use that schedule, and that schedule can change many times over the course of a day in some cases, but also be able to feed that data back up into ERP to do things like drive inventory and procurement directly. So essentially what we have is we have a shop floor to top floor communications loop that's all done in real time without human intervention. And the third one we talked about was the machine data. If we don't have these, our traditional approach, which is operator-centric all by itself, we get essentially reactive information, but we're generating lagging metrics. So our metrics are not in real time. An example of that would be companies that write, I was down for 10 minutes in setup, and I was down for 15 minutes in feed hold or whatever, and then aggregating that into a spreadsheet and firing it out to management the next day. That's a real lagging metric. We're having a production meeting the next day about something that happened yesterday. When you look at what happens in most manufacturing plants, three things constantly change: people, product, and equipment. And so any one of those three variables can actually upset that productivity number from the previous day, and the cycle repeats itself every other day. So when we have real-time information, we can do things like proactive alerts. We can actually see what's going on in real time. We can action on that data. We can bring resources forward to solve a particular issue. We can drive our continuous improvement initiatives, which I'll get to in a future section here. But essentially when we go from reactive to proactive, when we take these three data streams in real time and actually display them. We talk about data-driven manufacturing and how it comes alive. So we obviously need to get real-time data from the factory equipment and the people that operate it. That's absolutely key. If we don't have that, we're not doing IIoT on the factory floor. We need the production schedule. We need to be able to go back and forth between ERP. That's also key to the factory of the future. If we really want to get elegant here, we can do things like use RFID on our high-value tooling or our work in progress, so we can know where to send the fork truck driver or where to send the person who's doing the setup to know where the tooling carts are and things of that nature. And we do have customers that do this. The whole purpose of this is to drive costs out of the enterprise so we can actually become more efficient. And on our average internal return rate of capital is 300% or a 4-month paybacks. And we've done this 150 times with 150 different customers, some of them multiple plants, geographically located around the globe. This whole idea is to fuel a continuous improvement, a real-time continuous improvement initiative, so that we're not doing a Kaizen event where we end up collecting data for a day or a day and a half, and then we make a process change, and then we do another half a day or a day's worth of data collection to see whether it was negative, neutral, or positive. We can actually just run reports right out of the system and pick the improvement areas that we want that give us the highest value of return for effort expended. And then we can do things like we can have horizontal and vertical integration, so we can actually have our trusted suppliers be part of our supply chain, actually have visibility on what's coming up. So we have these pieces of landing gear that have to go out for surface treatment, or we have this particular batch of bearing races that have to go out for heat treatment. We can actually give them access to the system in a trusted way and have them see so they can plan their production schedule to meet our requirements. What does impactful continuous improvement really mean? So everybody that's doing a continuous improvement initiatives wants to do all of these things. They want better root cause analysis, they want to improve quality, they want to improve uptime. Obviously, on-time delivery is key. Real-time tracking of OEE is the business use case that I'm going to focus on, but there are many business use cases once you get your factory connected. Things like total predictive maintenance, things like big data and analytics to do trending and when a spindle bearing is going to fail and things of that nature. Once we have these machines properly connected and we're actually streaming the data into the application, we can actually do a lot of really cool business use cases, and ultimately return on investment is dramatically improved. And obviously we want to measurably improve our productivity and ultimately our profitability. And I'll go through a couple of examples of that in a minute. Now, here's what we want to reduce. We want to identify bottlenecks faster. We obviously want to reduce unplanned downtime. That's a key. Setup and changeover times are a big one. I mean, Schmed was invented by Toyota. It was a single-minute exchange of die. We want to get those setup times down as low as possible. We'll leverage our resources. Minimize unproductive labor. Obviously, everybody wants to do that because you're paying the labor anyway. We might as well have them do more productive tasks. Eliminate manual data entry and reduce costs and waste. If we have the circle of continuous improvement that's driven by real-time data, all of these things are possible. We can have all the uptick of the previous slide, and we can reduce all of these things. And the combination of those two directions moving opposite to each other actually dramatically increases the profitability of companies. We've taken companies from 30 to 35% utilization to 80 or 85% utilization. And when you think about that for a minute, that's like having somebody have another factory and a half of capacity that they didn't know they had. The average answer that I get when we ask customers about where do you think your efficiency is, where do you think your capacity utilization is, the answer I get is about 60 to 65%. The actual number on over 150 times we've done this is sub 35. So there's a perception reality disconnect between I think I'm twice as efficient as I actually am. The good news though is we can show exactly with real-time objective data where to go and get this lost downtime and this lost productivity. Benefits of impactful continuous improvement. Obviously we're going to have daily team meetings with real data. So remember I gave you this scenario where we had meetings with data that was from yesterday and it was latent. Now we can print reports out in half an hour before our continuous improvement meetings for exactly what happened. We can have meetings in the afternoon from something that happened in the morning. We don't have to aggregate all this data anymore. It's available to us. This is a concept that I like to bring to people's attention. We call support the internal customer, where the operator is the internal customer. And if we can bring everything that the operator needs to be efficient, things like tooling, dunnage, chip bin, emptying a chip bin, coolant, if you're using CNC machining as the manufacturing genre that we're talking about, but you could extend that to anything else, packaging or whatever. When we can have the operator hit one button and say, I need this, from a very simple to use operator terminal, what we've done is we've taken that person from a proactive to reactive role, sorry, not reactive to proactive role, but we've also given them the ability to be part of the solution, then rather than just simply pointing out that there's an issue. This is an example of a set of reports. I have hundreds of examples of this, but this is like a Gemba board that gets printed out with real-time data. And everybody uses this real-time data now to actually affect change, look for trends, concentrate our continuous improvement efforts, because we only have a limited bandwidth of continuous improvement, and we have more projects than we can take on. The ones that we do take on, we want to make sure we maximize the availability of those resources in order to affect change and increase profitability. I'll give you a couple of quick examples here. These are examples with a small and medium enterprise. So we'll just simply take 10 machines over 5 days, 8 hours a day, and a loaded labor cost of $85 an hour. If we look at half of those machines being hardware connected and the other half being essentially plug and play MT Connect or OPC connected, this is simply done for the costing of the project. We're going to concentrate on a really small increase in efficiency. So we're going to talk about 3 minutes to reduce, we're going to use 3 minutes of downtime per machine per hour, and we're going to pick up 2 minutes by increasing the visibility of the process. That's only an 8% increase in OEE. Well, we spent approximately $63,000 on this project, but we gave back the company $142,000 in the first 12 months. Just a little over a 200% internal return rate. But over the 3-year lifespan of this, we actually generated $452,000 of additional accretive income. I'll look at the same example again, but I'll actually double it. So we'll have 3 times the amount of machines, but we'll also run 2 shifts a day instead of just 1 shift a day. So we're still talking about 16 hours, $85 an hour. We've got 30 machines, 15 of them are hardware connected. Again, the same small increase, 3 minutes per machine per hour and 2 minutes per machine per hour. Same 8% OEE number. But here's the numbers. We spent $150,000 of capital on a project like this, but we saved $850,000, and over the span of 3 years, we generated $2.5 million more of income. All right, these are actual numbers. We have a return on investments calculator. We've done this 150 times, and in every single case, somewhere between 200 and 400% internal return rate of capital is the average. We have customers that even have more than that, but that's the average internal return rate. So what does situational awareness look like in the IIoT era? Well, it could look like this, or it could look like that, or it could look like this, or it could look like that. These are all examples of having that real-time data available to the operational management team to give them a completely different situational awareness tool to manage their factory floor and their operations. What's the factory of the future and the value of production visibility? So when we talk about that factory of the future and we say how, well, I'm a huge proponent of involving the operator. The operator is key both in the selection process and in the implementation process and ultimately the execution process after we go down the road of implementation. We absolutely have to have the operator be part of this. Otherwise, the entire system looked at like Big Brother. And that changes the entire culture of the organization. Culture is key to successful adoption of this technology and ultimately reaping the benefits that are promised. Teamwork. Because we have one version of the truth now, where we have one set of data that's objective, there's no subjectivity involved, then we can have people in all the different departments that require this, whether it be quality or production or operations, scheduling, maintenance, whatever. We all have one version of the truth now. So we can all rally around one set of data points that's accurate. So there's no more finger pointing, no more this is a production related issue or operations related issue or maintenance related issue. It is an issue. We know what the issue is, and now we can task as a group to solve it. So what we've seen is a lot of additional teamwork as a result of just getting rid of the infighting, get rid of the finger pointing. And then we've talked about this already about connecting the shop floor to the top floor, connecting our ERP system. We have a lot of data that's trapped in ERP, but it's not actionable because the traditional way that work orders are dispatched today without a system to accept them on the factory floor is go make this and tell me when you're done. And when a customer calls in and says, where's my work order, where's my product, and you can't answer that, you have to go put the phone down and say, I'll call you back, or respond by email, and then go find that work order and figure out where it is in the operation. You can actually give the customer a much more pragmatic answer if you can look at it on one dashboard. The when. Well, as I said, on average, 10 to 50% sustainable productivity increase. The investment's measured in months. Again, I haven't done this 150 times. We have the benefit of some empirical data. Utilizing a proven solution with management setting the course for the culture change, which is really important, reduces the risk of adopting this technology. And then I always say the time is now, because if you believe what I said about a 300% internal return rate of capital or a 4-month payback, if we started that on the first day of your fiscal year, we would have given the capital back to the company 3 times over the first 12 months. So production visibility on the factory floor, on average, we see a 6 to 10% productivity increase just by putting up and-on screens and not running one report. So don't have to run a report, and you'll get somewhere between 6 and 10% productivity increase, because everybody that's on the factory floor now has complete transparency and visibility about their area and how they're affecting the productivity of their area, how they're utilizing the equipment. And then increased machine operator awareness, and then how downtimes affect productivity. That's a key one, because you can watch this on a very simple speedometer to see what's going on right now, and if I ran this job before and I did it at 65% efficiency, and right now it's at 55% efficiency, I have a way that I can figure out where that other 10% is and fix it before the end of the day. Gemba boards and and-on screens. We see a lot of our customers run electronic Gemba boards where there's no more paper being printed out. There's just reports generated on large screens that the entire operational management team rallies around in the morning, gets their instructions for the day, and then goes and executes, and then can come back and see what's going on throughout the day. So it gives everybody in the entire factory a different situational awareness capability. And transparency, huge transparency when everybody can see what's going on now. And again, I said 6 to 10%. This is an example of one of our customers who runs their operation. The picture on the left is our friends at MEMEX. They have about 10 of these, maybe 15 of these big and-on screens throughout various parts of the factory. This particular customer here is the operational management, the cockpit for the operational management team, and that's how they manage the operations. And when they see one of those bubbles go red for longer than what they think is an acceptable amount of time, they can send somebody out or go out and say, hey, what's going on with this particular product, or what's this particular machine, or how it's being utilized. And what it's done for this particular company is take their OE from 40% to 82%. That took about 9 months. It's all the fuss about with IoT and Industry 4.0. So I like this stat. Every week I could read a different stat, and the number's big and the quotes are awesome, but I like this one because it doesn't really talk about one particular genre of manufacturing or one particular geographical location. It says 2/3 of the world's GDP is going to be affected by the transformation that this technology promises. And so whether it's 6 trillion or 12 trillion or some other number, it's a big number. A little bit about Industry 4.0, a little bit of for most people, a nebulous concept. How do I monetize Industry 4.0? What is Industry 4.0? I'm not going to get into the first 2 industrial revolutions because I wasn't here. I started in a little around the 3rd. But where we are right now is we're trying to converge these 3 ideas into one common theme, which I'll get to in a subsequent slide here. So when you talk about the industrial Internet of Things, again, we're talking about data from the equipment, we're talking about data to and from ERP, and we're talking about data from an operator portal, so we're actually leveraging these 3 data streams together, and that's another business use case of the IIoT. These are examples of IoT in manufacturing. There's probably 100 examples of where you can apply IoT in manufacturing. I'm going to concentrate on OEE because that's what we do. But there is, again, TPM, there's predictive analytics, there's predictive maintenance, there's all kinds of things that we can do with this data. And when we do it via MT Connect as an example, we can put in one set of infrastructure, one common set of infrastructure, and we start plugging in different applications that consume the exact same data stream, but create a completely different business outcome. And they're not interdependent with each other, they're completely separate. It's just, again, one consumption, one data producing layer, many consumer layers. So where we are right now in the connected manufacturing revolution is we're probably up here where what we call the data-driven manufacturing, connected manufacturing model with universal machine connectivity. That's not really that expensive. It's what we call it like a technological shift. It's from I have all these disconnected assets. Now I have all these assets. I have all this data flowing into one central server. What do I want to do with it? What do I want? What business outcome do I want to take on? So when you think about these three concepts, with IoT being coined by MIT around 1999 and Industry 4.0 around 2010 by the European/German government, I think it was the German government, tried to find a stat on this one of who actually came up with IIoT, Cisco, GE, 2009-ish, somewhere around there. But what I challenge people to do is think about a convergence of all of these three ideas. They're all kind of similar, but it's a little bit different, into one common idea with consolidated reporting, big data and analytics, corporate dashboards, all driven by real-time data. We call this entire concept data-driven manufacturing, or DDM. It's like this industry didn't need another acronym, but we created one anyway. It's data-driven manufacturing. So it's interesting when I talk to people about IIoT, and the question I get asked all the time is, well, how do I monetize an IoT strategy? So, well, why don't you think about it just call it data-driven manufacturing, because actually what we're doing is we're driving the manufacturing process with data. That seems to be understood a lot better than simply Industry 4.0 or IIoT. I want to talk about some myths and reality here. From myth perspective, with advent of this technology in manufacturing, it's a theoretical construct with no practical application, or an unquantified capital expenditure with no return on, or no quantifiable return on investment, or that it's a highly technical deployment strategy where the path is unknown and the costs are unknown. And the last one I like the best. It's not a magic bullet, or the myth is it's a magic bullet for every problem that manufacturing faces. The reality is that's not true. It's not a magic bullet for every problem. Let's talk about what it is, though. It's both transformative and disruptive, but both in a good way. It's a known and quantifiable payback. I gave you a couple of examples there, and I said that our average internal return rate was 300% or a 4-month payback. And it's a practical and proven, this technology, when applied in manufacturing, is practically proven to eradicate productivity gaps. And so increase from 35% to 65% is on the average example that I gave you. Average internal return rate of 300%, and it's available today. So this isn't an idea anymore, this is reality. Instead of having done this 150 times, I think we've connected about 7,000 machines in total, which is a drop in the bucket for how many machines are available to be connected just here in North America. When we talk about IT and OT, in order for these projects to be successful, we have to have a convergence of the two camps, because right now they're in very separate silos. So usually when OT comes to IT and says, I want to do something on the factory floor, I want to connect my assets, the first answer is no. All right, I've been in meetings where that's happened, so then there's a network that's put out there that's completely separate from the other network, because they don't want to tie it together with their business systems. In order to take full advantage of this technology, that has to change. That mindset has to change. Good for Mazak to take a leadership role in this and actually coming up with a smart box so that IT can actually finally embrace a device at the edge that they understand, same as what they have in the rack. They can take the same policy and procedure that they put on these large rack-mounted switches and apply them to this small little, relatively inexpensive level 3 switch. So what does IT care about? Well, obviously, IT doesn't want to have the scope never end and take up all their time and be one of these projects that never ends. They obviously care about physical risk and security. That's kind of what they're there for. They're to make sure that we don't get malware, we don't get ransomware, we don't get virus infected. And they don't want to support outdated or custom systems, because what happens eventually is OT just punts it over to IT, and IT is now stuck with this legacy system. What does OT care about? Well, they also care about physical risk and safety. Nobody knowingly wants to expose the company to bad things, right? So it's not a purposeful outcome. It's an unintended consequence. They care about productivity and quality control. Obviously, data leaks, especially when we're getting into sensitive type data or sensitive type manufacturing, whether it's defense, nuclear or defense. And their number one concern is working with IT. So we hear time and again from OT the complaints that, oh, IT is so difficult to work with, and on and on and on. This has to change. So when you look at a typical deployment of this type of technology on the factory floor, and you look at what IT cares about, well, they care about the networks. Everywhere you see the red, there's a network. They care obviously about databases. They care about the ERP system for the most part, and any interface with any other applications across the network. What does OT care about? OT cares about Obviously, in this case, we're giving an example of transferring programs to and from a CNC machine via distributed numerical control. They also, OT cares about putting in a system to take data from the factory floor from the operator. There's a lot of overlap here. There's a lot of places where these circles intersect, where these two camps have to work together. So this has to happen. We have to have convergence of IT and OT, where both understand that security is important and both understand that we can encrypt communications between machines, or between machines and databases, or between machines, databases, and even the cloud for that matter. And obviously ensuring the integrity of the data, and that being able to actively support an implementation like this in a way that brings both companies or both camps together within the enterprise. This has to happen. So we look at benefits to explore. We're talking about overall equipment effectiveness. These are some of the critical business challenges that have been identified to us by our customers. We'll see rising business costs, as everybody will say that. Productivity and asset utilization maximization, data collection accuracy, and obviously continuous improvement initiatives are very important. I don't know a company out there today that isn't doing some form of continuous improvement, whether it's the Toyota production system or Hoshin Cannery, or there's probably 5 or 6 other ones, or Kaizen events. So that's very important, and they're critical business challenges to our customers. Why does OEE matter in the IoT era? Well, it's become one of the most important metrics in manufacturing, because for the first time we can actually quantify a process in the form of a number. So we can actually take availability times quality times performance, and we can actually calculate, distill the 6 Sigma principles of waste down into one number. And world-class OEE is 85% or 95% in each one of these 3 categories. And as I told you earlier, most people think they're 65, the actual number is 35. So there's a huge opportunity to leverage the value of the OEE calculation to increase the productivity of the average factory to world-class levels. Again, availability times quality times performance. Availability is runtime divided by total time including downtime. That's an easy one, never more than 100%. Quality is good parts divided by total parts including rejects. Again, never more than 100%. The performance one's interesting because theoretically you could be twice as efficient. You could say my part takes 10 minutes to make, but I bought in some new tooling and I bought a new machine and now I cut that part in 5 minutes. So theoretically I'm 200% efficient. The reality is we should lower the product standard down to 5 minutes and do it again and do it again, and actually lower that bar, continue to lower that bar so that we make sure that we're not patting ourselves on the back for a false number. And we really see this as the gold standard for measuring manufacturing excellence. What drives the desire for OEE? Well, I said earlier, we reduce or eliminate subjective data and replace it with objective data. That's key. We shine a light on dark assets, so we actually light up the factory, so now we see what's going on across our entire factory operation. We talked about impactful continuous improvement, so driving our lean initiatives with real-time data. And we call the last concept, reveal the hidden factory. We've had companies that that were going to, didn't know what to do, was outsourcing work all the time. They couldn't make enough parts for the company. They would take on more work and they have to outsource that work. That's actually not very profitable. So when they were able to reshore this capacity back inside the 4 walls, there's huge benefits from a profitability perspective. Some of the roadblocks to look out for. Well, this is when we used to go to market with this technology, we used to talk about the how all the time. We talk about the gigabits and the this and the that, and how the technology and the all the inner workings of all the technology, communication protocols, all that stuff. Then we had a little bit of time on the what, some on the when, and the why, the business outcome, the real reason to want to do this would be the last thing that we would talk about. So what we do now, I challenge our sales guys to do now, is to talk about the why first. When you go to buy a car and a salesman, what does the salesman want to do? They want to put you in the driver's seat first, because they want you to vision yourself, okay, driving this car down the road and everything else. We do the same with the customers. We want to understand why you want to do this. What business problem are you trying to solve? And we bring our experience to bear, and a combination of those two things ends up in a solution that, again, generates about a 300% internal return rate. We spend a little bit less time on the when, and we spend the least amount of time now on the how. And that's important, because if the why is not understood, the how's irrelevant. We're never going to get a project funded because it's the fastest network or it's this or it's that. We're going to get it funded because we're going to actually give this capital back to the company, in some cases 3 times in the first 12 months. Some issues to consider. The why, the competitive advantage, the status quo is not acceptable. Culture of the company, as I said earlier, is a big one. This is a transformative and disruptive adoption of this technology is transformative and disruptive, and we want to make sure we manage that effectively so that we get the most out of the system in the shortest period of time. And then one of the other issues to consider is everybody says, I already have 5 jobs and now you're going to give me another one. So now tyranny of the immediate takes over. I want to talk a little bit about fear, uncertainty, and doubt. So from a fear perspective, we have fear of failure, fear of the unknown, fear of change, and fear of data and system security. We have uncertainty around the path forward and the quantifiable results. And we have doubt about the promised business outcome and again, this culture change, our ability for our company to change and morph the culture to be able to adopt and accept this type of technology. These are all fear, uncertainty, and doubt that we see with our customer base, so you should be aware of it. But what happens when we add up the doubt and the fear and the uncertainty, we get what's called the analysis paralysis problem. Because if we don't take advantage of this technology, and if you believe what I said about a 4-month payback, 300% internal return rate, and we wait 2 years, we could have given this capital back to the company 6 times to redeploy to buy robots and buy new machine tools. So it's essentially tantamount to lost opportunity cost. Some examples of some results achieved. If we looked at the company on the left under the actual, I said sub 40%. The bottom orange block is the productive times, in other words, where we're actually in cycle and producing parts under program control. But then we have all these other time wasters or time stealers like maintenance mode, setup mode, downtime, small stops, and speed loss. The factory on the right is our desired state. We want to get that production time, we want to get that green light on under program control as close to 85% as we can get. And it doesn't come from one thing. It comes from a whole keiretsu of small little process improvements. Things like reducing downtime, increasing quality, getting quicker to root cause analysis. Because I said there's 3 things in any factory that are constantly in flux. Labor productivity tracking. All these are like 1 or 2 or 3%, but they add up to a 10 to 50% productivity increase on average. All small little things. Some of the successes, and I'm not going to read all these, but you can see that on the left-hand side, this applies to a wide genre of manufacturing. It's not just good for aerospace or automotive parts or whatever. We have a lot of industries represented here and a lot of compelling numbers on the right. Some cases 60, 65% increase. And this is, again, a keiretsu of benefits that we've seen from customers that we've worked with, and whoops, not every one of those is, it's not applicable in every single case, but reduced operator overtime or increasing capacity utilization the first 3 months and on and on and on. Suffice to say, I'm sure that in your factories, 1 or more of these will be true. Maybe the numbers are slightly different, but it's definitely a delta from where you are to where you could be. So my summary here is technology is available today. Why wait? It generates a very compelling internal return rate of capital that can be quantified. The why should always be the first point that you discuss with a vendor. It shouldn't be about the technology. It should be about you the vendor understanding what it is you're trying to accomplish to make sure that the business outcome is aligned. The security, internet security has to be part of the discussion. If we just do this in a ad hoc network and something bad happens, it's horrendously expensive to fix, and we've seen it. With that, I think I'm done 6 minutes early, so I can take any questions that anybody has. No questions? Awesome. I said I would do this. We're done.